Okay, so I am not actually that interesting. So, I will tell you all the bad things that I've done, right? Bad in high school, got knocked up at 18. Don't record that, by the way. Anyway, the point is, the real superstar is in the back, Savannah. I hope you guys get a chance to meet her, my daughter. She's 26. She's in the quiet room, not being quiet. So I hope you guys get a chance. So there she is, pink headband. Hi, Savannah. Hi. Aw, there's my girl. Okay, so I do have to, I want to say one thing. The slides are all available. All the speakers are going to be sharing their slides with us. You don't have to take photos if you don't want to. And then I have to do something to the camera here. I have to say something and try not to look lame doing it. So help me out to not look lame, all right? And again, this is a great opportunity for us to tell our LGS stories. So it's really important that we do this because most of our kids don't have a voice like Savannah doesn't. So. Okay, so with that, I'm supposed to look at you. He's leaving. He's leaving. I can't look at the camera and do a direct to camera if he's leaving.
Yeah, you have to turn around.
Oh, I have to turn around.
Yeah.
Okay. Well, so much for not looking lame. All right, are you ready?
Yes.
All right. I am Tracy Dixon Salazar. My daughter, Savannah, has Lennox-Gastaut Syndrome. We are here at the LGS Lennox-Gastaut Syndrome Family Conference, and we are one of the 7,000. Okay, I got a thumbs up that was good, all right? Thank you. My lame will be on display all week. I'm here all week. No, anyway. So I want to talk to you guys about where we've been and where we're going, and I apologize, I am probably to blame completely for how behind we are on time, but we're so grateful. And hopefully you guys will feel inspired by this talk because years ago, Savannah was born typically developing healthy little girl, and she wasn't delayed, she wasn't precocious, and at 2, she had a seizure. Out of the blue, we didn't know that she was having a seizure, we didn't even know what seizures were. And by the time she was 3, she was having seizures every day, and she was having 6 different types of seizures. Her first 8 EEGs were normal, her first 3 MRIs were normal, we had no idea, and we were told she was gonna be fine. She was not fine. She was diagnosed with LGS at the age of 5, and this is pretty much what we knew back then. We knew that LGS consisted of multiple seizure types, that you had a specific EEG pattern, and that there was intellectual disability or cognitive impairment. And we know a lot more now. We also knew that anything can cause LGS. LGS is a group of symptoms. So it's like saying you have a headache and a stomach ache and your left toe hurts, therefore you have this group collection. It's not the cause of what caused your seizures. It's your syndromic diagnosis. And it's an important diagnosis because look at this community of people that's come together for this disease. But this is really all we knew. We knew that you had multiple seizure types, specific EEG, cognitive impairment, and we knew that it could be caused by pretty much anything that could cause epilepsy. Now, in today's day and age, we think about epilepsy in terms of the seizure types, but also the epilepsy types. We start looking at it like into Dravet syndrome or Lennox-Gastaut syndrome. We start to look at epilepsy across the causes, the etiologies, as you'll see in the red boxes there on your right. And so we're starting to, instead of just making therapies for the symptom of seizures, we're starting to look at research that looks at all of these things, the seizure types, the syndrome types, the epilepsy types, the causes, and then also the comorbidities. And that is not what we did back then. So let me tell you, I think one of the biggest breakthroughs that has happened has been in the causes of seizures that can lead to LGS. So if you just look back in 1975 and in 2014, this is what the graphs look like for causes of seizures, causes of epilepsy. And it didn't really change that much. It was things like head injuries or strokes, tumors, infections. We really didn't make a lot of progress in this entire year span. And the messaging back when Savannah was a kid was, thankfully, we don't need to know what causes seizures to treat them. Well, we tried and failed 26 different therapies from the age of 3 to the age of 18, and I can tell you for sure that that sentence is not true. We were also told that seizures don't damage the brain. Everyone in this room knows that they do. And we also know, we were also told back then that you can't die from seizures, and we also know that that's not true. And so it's really shifting now. Doctors don't say those things anymore, for the most part. Most doctors don't, because the science has now come forward. And we've identified a lot of different causes in epilepsies. And there's going to be a couple of amazing talks on genetics and how that relates to epilepsy. But there's been an explosion in genetics of epilepsy. So this is the old graph that's listed up there. And we identified a first epilepsy gene in 1995, and then a couple more. This is the new graph, and this is a slide from Dr. Heather Mefford, who's giving a talk, I believe it's on Sunday, on genetics of epilepsy. It's been a gene explosion. These are genes that are present at birth and in the kids. They might be inherited from mom and dad, they might not. And they are underlying the seizures that start in early childhood. And we know so much more about this than we ever did. And as was mentioned in the earlier talks from Dr. Porter, Dr. Coe, and Dr. Ches, we're starting to get an idea of which medicines to assign to which patients with epilepsy. So those of us that are old hats in this room, we've all just tried whatever. You know, you might as well grab a dartboard and just throw the dart at whatever med pops up. And that's how we did it. And thank God we had that. I mean, I'm not trying to complain about the way things were, but gosh, we could do so much better. Because after I think about the 10th drug, when people are like, look, I have all of these other 20 drugs I can try. I'm like, that does not excite me, because it comes with this whole host of side effects and issues and instability. And so it was really hard to get excited about the next drug. But we're making a lot of progress. And so this is what the map looked like starting in 2014. And what we think is that most of those epilepsies that were unexplained have a genetic cause. So the gene is present and it's driving the first seizure. And I'm going to talk about how that can lead to LGS in a minute. I just want to mention that Ingrid Scheffer is going to be giving a talk tomorrow morning about this. These are all of the genes and the different stages of life across the bottom, so 0 months out to 4 years, and where they play a role. It's not perfect. We don't know everything, but the science is really emerging, and there's over 100 genes now that are implicated in these early onset epilepsies where there's multiple seizure types and intellectual disability, and it gives us the idea that we can match up the right medicine, but also that we might be able to intervene if we can find these kids a bit earlier. So this is a great paper from Dr. Ann Paduri. She is not here. I don't know if you guys noticed, but our lineup of doctors speaking at this conference are the best in the world on LGS. We are so lucky to have them. Dr. Paduri is awesome. This is her paper where she sort of outlines what we know about which genes might go and coincide with which medicine, or which medicines to avoid, which medicines to try. This, by and large, is a very small number of patients that benefit from this. We know more about what drugs not to put patients on, but it's coming. And it's exciting to think about, oh, we identified this baby with this genetic disorder early, and now they could go on this drug early to prevent this evolution. So let me talk about this evolution of LGS. So this is what we knew back then. Let me tell you how we think about LGS now, and this is the world according to Tracy after my 20 years or so in this space. So this is where we are right now. LGS, you have more than one seizure type, you have a slow spike in wave on the EEG, and maybe some other abnormalities. Cognitive impairment is not required for the diagnosis. 30% of kids are actually normal when they get the LGS diagnosis. But within 5 years, that number goes up. So 95% of patients with LGS will be cognitively impaired within 5 years of getting the diagnosis, whereas 70% have it at the time. So it's not required for the diagnosis. And we know it, no matter what your cause of LGS is, the outcome is pretty much the same. The continued, I mean, look at our kids. Look at our kids, they all look the same. It's like custom issue iPad, wheelchair, and kinked neck over the iPad, right? Like, you know, and we're not even fazed by any of the seizures or the behaviors that are going on in here, because we're all like, please, please. That's the worst thing that happens to me today. It's a good day. So it's interesting. The outcome is pretty much the same. The seizures continue into adulthood. The intellectual disability continues. And then there's changes in seizures that happen. So what happens before this, though? There's this evolution. All of us start with a first seizure, and then it may happen instantaneously, but a second seizure will emerge, and now you have epilepsy by its simplest definition. And then at some point, multiple seizure types will emerge. So you'll have more than one type of seizure. And again, this may all present immediately. For us, it was tonic-clonic seizures, and then 6 months went by, and boom, we had 6 different seizure types. So it's different. Everybody's journey is different. But we all go from the first seizure to a second seizure, which is epilepsy, to multiple seizure types, to treatment-resistant seizures, and then we have the LGS diagnosis. And so at some point, at any point across this journey, the other seizure types can emerge. At any point across this journey, the developmental delay can emerge, but each of these represent a place where we can intervene. And right now what we do is we go, oh, you have LGS, and so we're going to sort of target this. And what we're talking about now in the research base is preventing LGS over time. Now, this doesn't really help me and my 26-year-old preventing LGS over time, but I'll tell you what, I would want that for any baby. Any baby. So, me. That's what I love about this crowd is you guys get it. It's whatever we can do to help the next generation and make it not as hard as it was for us older folks. So you youngins in here, you have a lot of great support, and it's awesome. So let's talk about the causes. What happens before the first seizure? And we think we have a good sense. They used to say 70% of LGS is structural. So you'll see something on the MRI, and that could be a brain malformation. The brain didn't develop right. Or it could be an injury. You can see birth injuries like strokes or lack of oxygen. And then 30% were unknown. But we now think we have a better sense. We have some good numbers coming out. They're not perfect, but they're coming out. We think that about 15% are genetic, de novo genetic. That number's going to go up as the science goes on. We think about 33% of our LGS, so there's people in the room that are injury. So an injury at birth, so like I said, lack of oxygen, stroke at birth. We think about 15% are infections, so meningitis, encephalitis. We also have metabolic. And so what LGS really is it's a disorder of the brain. You have whatever's causing your seizure, the cause of your epilepsy. So it might be you have a SYNGAP1 mutation. That's the cause. And you have LGS secondary to your SYNGAP1 mutation. And you can intervene at any of these stages early. If you know about the SYNGAP1 mutation, maybe one day we'll have a therapy to actually treat those kids. We're not there, but the science is moving in that direction, and we can only do better, to be honest with you. And then there's the evolution. And so what LGS is, and I really hope you guys come to Ann Berg's talks this afternoon, because what LGS really is when the seizures and the lack of control of the seizures take over brain development. And the brain connects itself, it wires based on electrical activity. And when you've got all these abnormal seizures happening, you have abnormal electrical activity going on. And so the brain does not wire itself right. And so Anne will say that LGS is really something has gone horribly wrong with brain development. And we have a chance to reverse it early. We also have a chance to make a difference. My kid at 18 found a medicine that changed our lives. I'm happy to tell you guys all about that later. She's walking, she's talking. God, does she talk? Oh, man. We can make an impact in these kids, but what if we could prevent? That's where the research needs to go. So there's a lot of research in that. There's a lot of research going on in the treatment of seizures. I'm not going to spend a lot of time on this slide, but this is kind of how we look. We get the diagnosis, and then we could go to surgery, we go to more medicine, we could go to even more medicine, we can go to diets, we can go to other types of palliative surgery, like, oh, we'll do a corpus callosotomy, and your seizures won't go away, but it might help. One type might go away, and we're like, sign us up, because we're living in hell over here, so sure, bring it on. We try everything. And so there is still more of this research. And here's just a graph of all of the drugs that came out up to 2010. I need to update this graph because there's a bunch that aren't even on here. We have companies that are making drugs for our LGS kids, and I hope we never lose that they're targeting the seizures in LGS, because some kids become seizure-free with every new drug that comes out. And we have many companies out here that want to talk to you guys about clinical trials for rescue meds, for new drugs that are coming out for LGS, and if you're interested in participating in research and clinical trials, please talk to them. Also, the scientists that are up here talking, I know Dr. Berg will be talking about her study. Please participate in those if you can, because it's our generation that's going to make it better for the next generation, and it's the next generation that's going to make it better. And LGS just hasn't had a lot of attention because we're all so tired. We're so tired. We don't have any time. So any little thing you can do, fill out a 20-minute survey online, I appreciate it. It really does make a difference. So lots of drugs coming out, and you guys can talk to the groups out there. These are the drugs that are approved now in LGS. We have 6 for seizures associated with LGS, and then we have a bunch of drugs that are associated. We have evidence, but they're not FDA approved for LGS that we can use. And we have the ketogenic diet, surgeries, and BNS. And all of these things didn't exist. So if you get somebody in here, we have a lot of people in the room who have kids even older than my 26-year-old, and you get them in here and they're like, yeah, we had phenobarb, right? And we had phenobarb. Right? Right? And Dr. Koh said that too, right? And so these options, while really frustrating, and I was one of those people that was like, meds, pharma, ugh, right? That was me in the beginning, and I've really changed because we're all in this together, and if anyone wants to help, I'm like, you want to help? Oh, come on. We could use some help, so it's a good thing that we have this. So I want to talk just a little bit more about this evolution of LGS here. Again, so you've already seen this evolution. So what if you already have LGS? I've talked about prevention early on. What if you already got it? The research for the first time, I have been looking for good research on LGS when you've already got it and you've got 16 years of damage under your belt of brain damage and brain wiring, where you're at. And for the first time in my life, I'm excited because the research, the technology wasn't there. And so there's some really exciting research. Dr. Porter showed this, and I think Dr. Koh did as well. This is a patient who had slow spike and wave and paroxysmal fast activity, and then had surgery, and then those went away and normalized. So you can reverse the dam. You can reverse it. That's a huge principle. Most of our kids continue on with slow spike and wave, and then when they become adults, that transforms into something else. Really still abnormal, multifocal independent spikes, I think is what ours is called. But if you could reverse this and make it better, then, Savannah doesn't have this anymore. So is that why she's learning? How do we make this a thing? And so they're starting to show it can be done, and they're starting to look at the brain centers that are responsible for slow spike and wave, which I've never met a doctor that's like, oh, yay, slow spike and wave, that's a good thing. Like, it's bad. We don't want it. We don't want abnormal background. We don't want seizures. But if we can start to understand the regions to target, maybe we can intervene. So there's some exciting research coming out of labs that are doing deep brain stimulation, that are looking at the structures. They're imaging kids. A lot of it's coming out of Australia. And they're really looking at the network involved in the issues that our kids are having, with the idea that what if we, instead of just making a med against the seizure, could make it against the center where slow spike and wave come from, if we can figure that out. And I hope we see that in our lifetime. Tech is moving fast, science is moving fast, but it might not be. But we fund that at the LGS Foundation. We push that forward. All the money that you guys raise, we fund science, and I'm not gonna go in a lot to talk about what we at the foundation has done, but we're pushing the scientists and raising our hand and saying, please research our disease, please make a difference, because, just look, we need a lot of help. And not that we're worse or better than anybody else, but just we want to be heard as well, so. And then lastly, I just want to talk about how we're pushing things forward on the patient-family experience. There's a lot of things we could improve today in LGS with just education and knowledge about how we're interacting. So we did a survey at the foundation, and 467 of you participated in that, and we had 17 different countries that people weighed in from, and it was amazing. The survey was only open for like a month and a half. And you told us a lot about your kids that we're now going and sharing, and there were some surprises in there. And industry is really interested in this. Physicians are like, I didn't know that. Oh my gosh. Drug makers, the FDA, researchers, and there's even better studies that are coming out. Again, like Ann Berg, not to pick on her, but her study is going to be coming out too, and she's doing this in a different way, where she's looking at how we're interacting and how we're surviving, and what are the issues. Like, okay, make a drug for seizures, but could you make a drug so we can stop going to the ER every time Diastat fails or the rescue meds fail? Like, I'll line up for that drug, but no one seems to care about face injuries or broken kneecaps. Sorry, Aiden, my boy. Or it's like no one's tracking that and trying to make it better. So anyway, so most of our online population that filled out the survey is between 16 and 25 years old. This is the age breakdown. And they're having anywhere between, so 80% of us that answer this are having more than 2 seizure types, between 2 and 10 different seizure types. So we are having a lot of seizure types. And that's a problem because drugs target a single seizure type, and they often will make another one worse, as you all know. But we can begin to start to break this down. What is the most problematic seizure type you're dealing with right now? Generalized tonic-clonic seizures was number 1. Tonic was next, and then atonic. Doctors will tell you, actually, that we're actually really good at controlling generalized tonic-clonic seizures. We have really great meds for that. I actually heard that quote 2 months ago from a woman I really like, Dr. Jackie French. We don't over here in LGS, you know, and so how do we get some of that great generalized tonic seizure control over here? And what are we doing about that? So we can start to say, no, that's actually not the case here. In addition to that, we're on a lot of treatments, so over 80% of us were on 2 or more, some on more than 6, and we have some information from this on the most common treatment with clobazam or Onfi being the biggest. We're all on the VNS, or we try it usually, and then many of the others. So that's important, and we want to start putting this out to you guys. So how many times do you guys see on the Facebook group where it says, tell me about valproic acid, go? I mean, it comes up over and over on the page. We actually have some data now about how many are on it and what parents think of it. So do you think it worked? And none of you are surprised to hear this, but most of us didn't think the drugs worked all that well in our kids, but some worked a little better, so we're gonna start putting that information out soon. We talked about what types of seizure the person was having at this time. They were having everything, and they were reporting weekly seizures. And we started to dig in a little bit to this idea of, say, daily seizure variants, and I think this is kind of unique to LGS. We have no idea when the seizure is going to strike. And in addition to that, they strike at any time anyway, so even if we did know that they mostly come between 6 and 8 a.m. in the morning, it doesn't help us because it could still come at 7 or 9 or 12 noon, you know. And so this concept of daily seizure variants, I had Dr. Jeff Buchalter, he's given a talk about mortality and SUDEP on Sunday. He goes, when you talked about this for the first time, Tracy, it's the first time I really kind of thought about it. But if we could find a drug that can find all the seizures to a time block of the day, we'd all be lined up out the door for it, wouldn't we? Right? But nobody's looking for that drug. So, and these are just Savannah's graphs where you graphed her seizures over the month and there's no pattern. And then these were her seizures over the years. There's no pattern. And then finally, we asked you guys, you know, what are you still dealing with? So there's this big movement in epilepsy drug development and therapy development to start focusing on the comorbidities. Let's put our kids on drugs for sleep. Let's put our kids on drugs for autism or drugs for behaviors or whatever. And it's like, we're still having seizures over here, guys. And it's really hard to imagine the speech getting better if they're having 100 seizures a day. So for us, it's been like, hey, don't forget about the seizures because there's no such thing as something that's not seizure related in our family, whether it's eating. I mean, you know, we could probably stop seizures if we put all our kids in a coma, but then they're not eating and they're not interacting and all of that. And so still dealing with seizures, a lot of us are dealing with sleep disturbances, head and face injuries, severe developmental delay. So this is gonna be coming out soon and I hope you guys will enjoy it, but these are so important to be talking about these issues and what we prioritize at different stages. Like early in the journey for LGS, it's like stop seizures, stop the seizures. But then later on, we're like, can they just not sleep 19 hours a day? And actually tell me if they're in pain or hungry, you know, it changes. So, and then there was a study that the Epilepsy Foundation also did on this, where they looked at our kids, and our kids are having 1,000 to 5,000 seizures as reported across the last 6 months, whereas a lot of the other severe epilepsies are having way, way less seizures than we are. And so we need some help, and this kind of research really helps. So this is what we do at the foundation. This is my last slide. We take the science that's coming out of the lab, and we try to push it forward as fast as we can. We are a science-based organization, but sometimes science can't help us. And so doing surveys for trend data, just what did you try, did it work? Getting information that's out there, like Dr. Ches talked about one patient with the 7q deletion, I think it was. I'd not heard that story. It's like, great, try your next one on that, because otherwise you're just gonna go on this long journey for medicine. So please, if you wanna help, be involved. If you can do a 20-minute survey online, even if it takes you a month to finish it. If you guys want to know more about our research projects, clinical trials are up and running and they're always looking for patients to do it. And then, and then just really think about how we are sort of laying the groundwork for the next generation to get better. But most of all, just be inspired that it's getting better. It's so slow. It's so slow. And I'm both a scientist and a mom, and I want it to be fast. But we want to do it right. But we also, we don't want to wait forever to help the people today. And I think we could do a lot of that with education and with trend, like surveys and trend data and stuff like that. So with that, I just want to say I'm around for the whole conference, so please come talk to me. I hope I didn't go way, way over my 20 minutes. And thank you for being in my lame section with me. Yay, lame section! No, you guys are not lame. You're amazing. Awesome. And with that, I will turn it over to Christina, who's going to introduce our next speaker. Thank you.